another and very important concept is the integral of velocity. It says assume an object is in linear motion, so the position function, with velocity v of t. Remember, the way that you find velocity function is you take the derivative of the position function. Or, if you're given the acceleration function, the way you get the velocity function is take the integral of the acceleration function. Now, here's what's crucial. Some vocabulary. Displacement is, like, for example, if I start at this point, if I walk 5 feet to the right, and then I turn around and walk 5 feet to the left, the displacement is actually 0 because I'm ending up where I started from to begin with. So displacement is the distance that you traveled from where you started. In this case, you ended up right back where you started from, so that would be 0. As opposed to distance, same scenario. Let's say I walk 5 feet to the right, then I turn around and I walk 5 feet to the left. Even though I did end back up where I started from, distance is different. Distance is the absolute value. So in this case, the total distance traveled would be 10 feet because the absolute value of -5 would be 5. Now, what that means with integration, if you ever are asked to find the distance traveled by an object, you take the absolute value of the function, or if you're given a graph, remember the definite integral is the area up under that curve, then the distance traveled would be the absolute value of those areas. All right, for example, let's say a particle has velocity t cubed minus 10t squared plus 24t. It says write and evaluate an integral that represents the following quantity. Well, for the first one, it says a displacement over 0 to 6. So with displacement, you're not going to do anything but just simply write the integral. So let's see what that's going to look like. That's going to be the integral from 0 to 6 of my function t cubed minus 10t squared plus 24t dt. So that's how you find the displacement. Just simply evaluate the definite integral of that function on that interval. Now, notice the difference. If it asks for the total distance traveled over the interval 3 to 5, you would still do your lower limits 3 and your upper limits 5. However, total distance is the absolute value of the function. So it would be the absolute value of t cubed minus 10t squared plus 24t dt. So you would obviously get two distinct and separate answers for this problem. Now, one way that I could get my answer would be to use my graphing calculator to actually plug in the distance, not the distance, but the displacement, and my calculator gives me a displacement value of 36. So then that would be my answer for the displacement over the integral from 0 to 6. And I could also do the same thing for the total distance traveled. Notice I changed my limits from 3 to 5. I put ABS for absolute value symbols, and then I'm just going to hit enter, and the calculator gives me 7.5 as my answer. So displacement would be 36. The total distance would be 7.5. But just remember that total distance is the absolute value of the velocity function.